Morning and welcome back to AP Physics. I wonder how many times this is going to happen. I thought I was recording, but I wasn't, so I got through most of this lesson and then realized I wasn't recording. So it happens. So these are the three equations that we have so far. Average velocity equals displacement over time. Average velocity is equal to v2 plus v1 over 2. We can only use that equation if acceleration is constant, which is going to be the only types of problems that I give you. And then final velocity equals initial velocity plus acceleration times time. So what I want to do is give you a little bit of practice just working with these three equations before we get a couple more, and we'll start with this. So I'm going to try to draw on the screen. It doesn't really work terribly well, but we'll do our best. So let's see. A car accelerates from rest. That tells us that v1 equals 0. Okay. 48 meters per second. That's the final speed. So V2 does not equal 0. Sorry, V2 equals 48 meters per second. And we're given that the time is 8.9 seconds. How far did this car travel? So we're looking for, we've got, oh, this is going swimmingly. Well, if we're going to figure out displacement, right now we know we're going to have to use this equation right here. And to use this equation, I need to know time, which I know time, and I need to know the average velocity. Well, I don't know the average velocity, but I know the initial and the final velocity. So what I want to do is use this equation, plug in my initial and final velocities, divide by 2, and then use that to find the displacements. And that's what I do in this slide right here, listing everything out. Now, I'm not going to spend a whole lot of time. I'm figuring you guys can pause and review these a little bit with a little bit more time than what I'm going to put on here. But anyway, I'm still going to go through these. A roller coaster starts from rest and accelerates at 6.8 meters per second squared for 18 seconds. How far does it travel? Okay. So it starts from rest. Which tells us this marking on this just works out great. It tells us that our v1 is 0. Our acceleration, that's our acceleration number because it's measured in meters per second squared. And the 18 is our time number. Okay, and we're looking for how far does it travel. Okay, so again, if I want to know how far it goes, I need to know average velocity and time. I know time, but I don't know average velocity. Okay, we'll go to the equation number 2. I know initial velocity, but I don't know final velocity. Well, let's try equation 3. I can use equation 3 with my initial velocity, acceleration, and time to find v2, plug v2 into this equation to find v bar, and then plug v bar into this equation to find delta x. And that is what we do on the next slide. And this is what we do here. Problem number 3, a car initially moving at 13 meters per second accelerates and travels 120 meters in 4.5 seconds. What was its final speed, assuming the acceleration is constant? Okay, so so it gives us our initial velocity again. It uses the word accelerates, but it doesn't give us the acceleration. It gives us the displacement. And it gives us time. And we're looking for v2 equals question mark. This is wonderful writing on here. This is the drawing on this I thought was going to be a great tool, but it really didn't end up being that way. Okay, so what's the final acceleration? So we need to use this equation. If we're going to find the acceleration, we need to use this equation because this is the only equation that's got a in it. So we need to know v2, v1, and t. I know v1. I do not know v2. I'm looking for v2, not acceleration. So I'm going to use one of these two equations. Let's see, what can we find? So I've got displacement and time. So that'll give me v bar. Okay, and then once I know v bar, I can use this equation and plug in 13 for v1 and get v2, and that's what we should do. And that's what we do in this slide right here. Okay, sorry, going back, I went through that one kind of quick. Number 4, A car starts from rest and reaches 60 meters per second in 45 meters. What was the acceleration? Okay, so here we're needing to use this final equation because we need to know the acceleration, which means we need to know v2 and v1. Okay, so let's take a label what we have. It gives us v1 is equal to 0, as frequently happens. Reaches 60 meters per second and 45 meters. That v2 is 60 meters per second. And the displacement is 45 meters. What was its final velocity? Or what was its acceleration, sorry. Okay, so what I can do is I need to know the time. That's what's missing in this equation. So what I'm going to do is I'm going to use v2 and v1 to find v bar. Okay, then I'm going to plug v bar into this equation with displacement, and I'm going to find time, and then I'm going to use this equation to find acceleration, and that's what I do here. What's the initial speed of a car which finishes a 600-meter race at 65 meters per second if it did so in 12 seconds? So here, what is the initial speed of a car which finishes a 600-meter race at 65 meters per second if it did so in 12 seconds? So here we're looking for v1, and it's going to zoom in on me. Whatever. The displacement is 600 meters, so that's delta x. And we've got v2 is 65 meters per second. v2 is that. And it did so in 12 seconds, so I'm given the time. So what we need to do is figure out v1. There's two equations with v1 in it. Let's see what we have enough stuff to find. Well, I know I've got displacement and time, which means I can find v bar. And once I find v bar, I can plug in v2 and find v1 into this equation, and that's what we do here. Let's see. So a car starts from rest and accelerates at 3.5 meters per second squared. How far has it gone when it reaches 25 meters per second? So we're given v1 equals 0 again. Oh, this never works. Why is this such a... We're given v1. Why is this such a pain? We're given the acceleration is 3.5 meters per second squared. How far has it gone? So we're looking for a displacement. That's my question mark. When it reaches 25 meters per second. So we got v2. Okay, so let's see. I want to figure out how far it's gone, which means I need this equation here. I need to use v bar equals delta x over t. In order to know that, I need to know, in order to figure out, I need to know v bar, and I need to know time. Well, right now, I don't know v bar or v time. So what I'm going to do is I'm going to plug in v2 and v1 into this equation and get v bar. I'm going to plug v2 and v1 into this equation and acceleration and get time. And then I'll use those answers in the first equation to get the final answer. And that's what we do here. All right, so now you should be able to do up to worksheet 2.5. So good luck with those. Always feel free to ask me if you have questions. That's what I'm here for. And good luck.